This episode is a true test of my explanatory skills, right? Because in any statistics textbook, this section, which is bell curves, takes anywhere between 60 to 100 pages. And like I said, we're not going to go into the math, so that'll save us a few pages. I'm not going to make you do any exercises. I'm going to briefly explain to you what things mean in as visual a way as possible. So what I've done is I've compressed about 100 pages, 60 to 100 pages of most statistics books into 4 slides, right? And I don't know if I'm able to get the point across as quickly as possible, but the goal is to try to show you visually what certain things mean when it comes to statistics, right? So bear with me with this episode, but we are going to talk about bell curves. Awesome. So assume you qualitatively describe data, right? And you have these ranges and you have some frequency in these ranges. What if you took things with the maximum frequency and put them right in the center? So as you can see in this image on the left, all the things with the maximum frequency are put in the center. Let's just assume that happens, right? So what you can do is you can actually draw a curve. And I've shown you this before. You can draw a bell curve. Now, when you do this, when you draw this curve around data that's arranged like this, right? Where some of the data with the lowest frequency is on the far left and other data with the lowest frequency on the far right. Obviously, this is low values, this is really high values, but you don't find too high frequencies of these. And this is very common in most sample sizes, right? So if I take the ages of all the people in some place, you would not find too many super old people, right? That would be on the far right. And you wouldn't find too many very, very young babies, maybe 6-month-old babies. That would be on the far left. So those are your extremes. Whereas people who are between the ages of 20 to 30, they might be, very, very frequent in a particular place, right? That's how normal distributions work. And you can draw a curve around that, right? And as we've studied before, the mean, median, and the mode are somewhere around the center of this curve, right? So this is how a normal distribution is. We also call it a normal distribution. I like using the word bell curve. So let me give you a quick example of bell curves. So in the office, you have some poor performers. Very, very few people perform poorly. And then you have some people who are very high performers, right? They're at the extreme edge. And there's the average performers, and you're very likely to find these average performers there in the center. Now, if you've seen, for example, the management part of this course, you'll know that a lot of managers are asked to grade their employees by bell curve. They're asked to say, okay, that subordinate of mine is a poor performer, right? I'm going to mark him lower on the bell curve. This person, average performer, going to mark him in the middle. This person, really high performer. And when you make managers do this, and if they have enough people under them, they're very likely to mark a lot of people as average performers, around the average. And some people obviously will be really poor performers. Some people will be really high performers, but you won't find too many of them. The frequency is highest at the center. So now I want to explain or introduce to you guys the concept of standard deviations. So assume I take a bell curve, and what I'm going to do is I'm going to equally split, starting from the center at 0. I'm going to mark the center as 0. I'm going to have equal splits all the way till the very ending on both sides. Equal splits. And as you can see, each of these splits is represented by the symbol sigma. So 0, then you have some equal distance and you call that 1 sigma. Then you say 2 sigma, 3 sigma, and same on the left. You have -1 sigma, -2 sigma, -3 sigma, and you can keep going, right? But those will be smaller and smaller and smaller fractions. So most of the people, and you'll see 34.1% of the people lie between 0 and 1 sigma. Then 13.6% of people lie between 1 sigma and 2 sigma. And then 2.1% of those lie between 2 sigma and 3 sigma. You only find 0.1% of people. And this could not just apply to people, it could apply to anything with a normal distribution. And the reason we use things like standard deviation is because it's easier for us to talk about things. I could say something like your IQ, that's intelligence quotient, is within 1 standard deviation of normal, which essentially means your IQ is normal. So I can tell you that your IQ is 2 standard deviations above normal, yet lower than 3 standard deviations, right? Which means that you lie in 2.1% of the population. Right? You're somewhere at the top. And I could also say your IQ is 2 standard deviations below the normal, right? Which means that then you will lie in the 2.1% of the bottom, right? So this is where standard deviations are useful. We can talk to each other and say, hey, this is one standard deviation above, this is within 2 standard deviations, this is within 3 standard deviations, and you can keep going, right? If you do 6 standard deviation, that's a very, very, very tiny fraction, 0.000 something, right? So standard deviations allow us to, kind of map out territories which are equally split, yet the curve keeps fading, right? So this is the idea of standard deviations. So one thing you need to know is that 68% of the distribution, and we've talked about this before, 68% of data lies within 1 standard deviation of the mean. And as you know, the mean is in the center. 95% of the distribution lies within 2 standard deviations of the mean. 99.7% of the distribution lies within 3 standard deviations of the mean, right? And if you look, all of these, and if you look at both the left side and the right side together, these are called confidence intervals. So you can see on the image on the right, you can see there's a 68% confidence interval between -1 standard deviation and 1 standard deviation. There's a 95% confidence interval between -2 standard deviations and 2 standard deviations. And there's a 99% confidence interval between -3 and 3 standard deviations, right? So this is important for you to understand. And these are just essentially approximations, right? And again, we're not going to go into the math of actually pulling out standard deviation numbers or pulling out confidence intervals because that's not necessary. I want you to understand the general idea of the concepts by looking at it visually. So that's it for this episode. I know that you expected a much longer episode and that you thought that we'd go through 100 pages worth of content. We actually did. We didn't run through any problems. We didn't go through any definitions. I just showed you visually what these different things are, what standard deviations are, what the sigma symbol is, how bell curves work, how normal distributions work. And I just want you to see it visually so you have a rough understanding, or you have enough of an understanding for you to be interested in something like this, right? And I want, there's some further reading on this that we're going to attach, and you can read through it if you want to understand the math behind it, but it's not necessary to continue with the course. First, love the course. Love how we're making it easy to understand harder concepts, then dive deeper into the concepts. Catch you on the next episode.